Welcome to chemistry class. My name is Amy Lumley if you didn't see the earlier video, and I will be your instructor for this class. This is the start of chapter 1. Each chapter will be usually broken up into a couple different parts because I'm trying to keep the videos fairly short, I like to talk a lot, as you'll find out. The first chapter just gives you a background, a little bit about the chemistry in our world. So we're going to talk about what chemistry is and what chemistry is not, and how chemistry is used and what kind of chemists do, and how you can apply chemistry to your everyday life. But to start with, I want to do, a little scenario. So let's try this one. I want us to transport ourselves back to 1962. And you're like, Miss Lumley, really? This is before I was even born. But hang with me here. It's before I was born also. 1962. What was going on in the world? The Cuban Missile Crisis was occurring. Marilyn Monroe was found deceased in her hotel room. The first Walmart store opened. 1962. Along with the first Walmart store, the first Kmart store opened. On the shelves of that Walmart and Kmart, you would have seen the first flavored potato chip. What flavor, you might ask? Nope, not barbecue. Nope, not sour cream and onion. It was salt and vinegar. That was the first one. The first oral polio vaccine was given. Algeria and Jamaica gained their independence from France and England, respectively. The first Beatles song was released, Love Me Do. If you watch TV, you'd be watching the Beverly Hillbillies or maybe the Dick Van Dyke Show. And if you stayed up really late at night, Johnny Carson just took over the Tonight Show. So that gives you a little idea of what was happening back in 1962. Now, what we're going to do is, in particular, we're going to look at a hospital in Binghamton, New York. In their nursery, they were having a problem with some of the babies. The babies were getting fussy, especially around feeding time. They didn't want to drink the formula. They would spit it back. They would gag. They would vomit. And this had been happening almost all week. On Friday, 3 of those babies passed away. On Saturday, 3 more. They thought it might be a virus, so they tried to isolate. No luck. Nothing was helping. On Sunday morning, one of the nurses went to make herself a cup of coffee. And to sweeten the cup of coffee, she went into, they had a formula room. They had a room where, like a little kitchenette where they made formula. So they didn't get the Similac and the Enfamil off the shelf that we normally get. They actually made their own. And when she went to sweeten her coffee, it wasn't sweet. It was really, really salty. What had happened is that when someone had went down to the kitchen, the main kitchen, to get the salt and the sugar, they were sitting in great big pails side by side. And they think the lids had gotten switched. So instead of grabbing the sugar like they were supposed to, they grabbed the salt. Well, now they've figured out kind of what the problem was, but how do you fix it? How do you make it better for those babies? This was the first incident of a mass, huge salt poisoning issue. Now, if you remember, I said some of the babies, nearly all the babies were sick. Not all of them. Those that were breastfed were fine, and those that had a patented formula were fine. So if they were on Enfamil or Similac, they were okay. So what the doctor did is they went in and they took a syringe and put it into the stomach cavity of the children. They inserted sugar water, and then a little while later, they would draw off a similar amount of liquid, and that liquid was much saltier. So what they were trying to do is to replace the liquids that were already in the stomach. It worked. It did work. It took many, many hours of doing this. But all but one of the remaining babies were taken off the critical list, although some were still sick. Now, it is estimated that those babies took in 1 tablespoonful of salt. You think about when you're cooking, how big is a tablespoonful? That's how much salt they ingested. And if you would compare that to an adult, that would be about the same as an adult taking in 4 pounds of sugar. This is a huge amount. It threw off the baby's electrolytic balances in their bodies. But why is it that salt and sugar that look so similar to one another, why do they behave so differently? Well, let's see a little demo to see if I can get this to demonstrate for you. So in front of you, I have two different samples. I have sample A and sample B. One is salt, one is sugar. And to tell you the truth, I don't even remember which is which. Could you tell just by looking which is which? So what I'm going to do is I'm going to take this and I'm going to pour it from one container to another so you can kind of see, does it look different when it pours? Does it act different? Normally the first day of class, I will actually hand these samples out if you were in the classroom and have you examine them without tasting. That would be cheating. Could you tell a difference just by looking? So think about it just a minute. Do you have in mind which is which? Okay, we're going to try a little demonstration with it. All right, so now for the demonstration. What you should see in front of you are your two samples, A and B, and then there's a beaker of just water right behind it, also labeled A and B. So what I'm going to do, let's see, I have to stretch around the table here, this is a conductivity tester. Hopefully you can see it. And it has two electrodes at the bottom. Notice they do not touch one another. And at the top, it has a light bulb. If something conducts electricity, we have to complete this circuit to make the light bulb light up. So we're going to put this in just plain water. It's just plain water. That's all it is right now. Will water conduct electricity? Let me plug it in really quick. And you will see that water by itself does nothing. So I'm just proving this is water. And let's stick it over here. Oh yeah, that one's not doing anything either. So these are just plain water. Water by itself does not conduct electricity unless it has ions in it. Now I'm not saying, I am not saying that you should go throw a toaster oven into your bathtub because your bathtub uses tap water, which does have ions. Just don't do that. But what I've done is I've used some deionized water. So this is fairly pure, not exactly pure, but pretty pure. So what I'm going to do is I'm going to take sample A. I'm going to put it into the beaker that's labeled A. I'm going to mix it up. I'm going to take sample B. I'm going to put it into the beaker labeled B. I'm going to mix it up. And we're going to see if salt and sugar react differently. I added a lot, that's why they're not completely dissolved. Take those out for you. Okay, and so let's go back and see whether or not whatever is in salt and sugar, whichever one it is going to complete this circuit and allow a charge to carry. So we'll put it into sample A first. Let me plug it in really quick again. And what you'll see is the most boring experiment in the world because, lo and behold, it didn't do anything. Okay, let me rinse them off. Let's put them in the other one. This is sample B. And did you see that? On sample B, it lit up. It lit up really brightly, in fact. So what this indicates is that whatever B was is an electrolyte. It's something that conducts electricity when dissolved in water. Now, where have you heard about electrolytes before? Yeah, you got it. It's in good old Gatorade. So Gatorade has electrolytes in it. Well, what does Gatorade have? Well, Gatorade is sweet, so it must have sugar. But it turns out it's not the sugar. Sample A was sugar. Whenever you put sugar in water, that molecule of sugar likes to stay together. The salt in sample B It likes to break apart. Once it breaks apart, you have ions in water, and those ions will conduct electricity. So sample A is sugar. Sample A is sugar. Let's go ahead and write that down. Sample A is sugar. Sugar is a non-electrolyte. Electrolyte. Sample B was salt. Salt is an electrolyte. Sorry, my pen's not writing too well. There, that looks much better. It breaks apart when you put it in water. It will conduct electricity. Now, the Gatorade that you drink actually has a lot of salt and sugar both. They put the salt in there to act as an electrolyte. They put the sugar in there so that it tastes just a little bit better. Now, what happened with the formula in those babies? They were supposed to put in sugar, which is a non-electrolyte, but they put in some salt. And whenever they put in the salt, it threw off the electrolytic balance for those children, and their bodies just couldn't handle it. So hopefully that demonstration helped you realize that even though two substances can look almost identical to one another, there are some differences. There's something that makes them very unique compared to one another. Well, here's another, I don't know, just a quick little view for you. This one has a close-up picture of white sugar versus table salt, and you can see even the structure of those substances looks different. On the bottom, we have ground coffee and a grain of pepper. I thought that was kind of cool. One of the interesting things about chemistry is that as we go through, you'll find out that this is not a unique situation. Two things can look very similar to one another, but their characteristics are very different. I want you to appreciate some of those differences. So in this class, we will learn about some of those differences, why certain compounds behave the way that they do, how we can predict how a compound might act, and then see how all of this chemistry can fit into your everyday life. So buckle up. Welcome to chemistry. Get ready for a hopefully interesting ride.